Thank you. It's for those of you who would like to install the headphones now. Again, excuse me for that. My job at Schüco is to agitate in the direction of innovation and to understand a bit what the potential futures are. And one of the potential futures, apart from AI and a lot of other things, is of course climate change that we've heard a few times today. This image is from Dubai, middle of April this year. A huge storm. You might have heard that people were saying this was cloud seeding, forcing clouds to rain, which they do in Dubai. But this storm was the size of France. The amount of water in this storm was massive. And there was so much rain in certain areas that, for instance, in Oman, a whole bus was swept away, 9 children died, they drowned in the floods. It was unexpected, and it was probably just a forebode of what is still to come. And this has happened because of the change of the jet stream and not cloud seeding. So what is happening? We can see the trajectory of the CO2 emissions, and we can see the connected possible climate change, the projected temperature change. And the temperature changing means that a lot of other things change. For instance, the flow of the jet stream, the oscillation of the jet stream, the sea temperatures, the amount of water stored in clouds, etc., etc., etc. So there's a lot of things that happen because of rising temperatures. And the average global rise of temperature last year was 1.3 degrees. But that is sea and land. If you take out sea, it's 1.8 on land. And Europe is one of the fastest heating continents. And this leads to a lot of countries developing risk maps. They're assessing the potential risk and how resilient the country is and certain regions are. And you can see this is the risk map from the French government, and you can see there's areas which are more at risk to climate change than others, and these risks can be very, very different. It can be potential fires, it can be potential overheating, it can be heavy rainfalls and flooding, and they can be at the same spot in different times. Australia has a lot of problems in that direction. There's areas that are super arid and super wet in different times of the year. And we can see that over the past 27 years, the amount of events, or the percentage of events, the highest being flooding, and at the same time, on the right side, you can see the amount, the impact it has on humans. And human death is connected to heat, not so much to the water problem we're getting. And this is costing huge sums of money, and this is costing a huge sum of lives worldwide. And this is growing, and this is why everybody has to act. And as we saw, the curve is exponential. It's not a slow linear growth. The pressure is going to increase. It's going to have to increase because it's economically and also it's economically sensible, and it's also protecting people's lives. And more discussion is on this subject, and we can see that The Economist in April had a title story on it, making it clear to people that this is a huge shift in economical logic. And we can see that there's startups going into this area, making it viable to assess the quality of a property before I buy it. And insurance companies are reacting to these risks. Huge costs. The whole risk management is changing. And there's areas in the world where you can't even get an insurance for these risks, which means the properties are basically not of any value, and at least in the next couple of years, the value will degrade, and that is exactly what The Economist was looking into. And the European government has looked into the quality of insurance in all European countries. France is on the good side. Germany has problems. Netherlands has problems. So a lot of properties in these countries will be basically worthless because we won't know how hard climate change will hit these properties, and if it does, nobody's going to pay for the damage. One of the issues in France that will be growing and where France is a bit underinsured at the moment is fire due to droughts. This is something that the European government has assessed. In Germany, a lot of people are underinsured for flooding. And as you know, flooding has just hit us again. And by the way, it has also hit one of our properties at Schüco. And all this climate change, to put that aside, we all know it's happening, but I think it's important to always reconnect to our importance in this climate change as a business, as part of the built economy. So we all know buildings are approximately 40% part of the problem, using energy and using material. And material is a huge issue. If we look at this chart, we can see that the millions of tons that are sourced from the earth, that are extracted from the earth, is growing exponentially. We keep reusing material, putting it to the side, wasting it. And every recycling process needs more energy to decompose the material and recompose the material. So the best idea would be to reuse as much as we can. We all know that, but we have to do it in the building sector, which is happening at the moment, which is why we're here today and discussing this so much. And how large is the part that we have in the facade industry? Well, it's about 25% of the overall consumption in the building industry. And this is glass, this is everything that goes into windows and doors, which means it's part of our part of the business and our responsibility at Schüco, of course. And there's been a lot of addressing of this topic in regulation, and one of the EU norms has looked into the whole life cycle, the carbon emissions in the whole life cycle of product. And it's changed a lot. We used to focus very much on the operational carbon side. How much energy are we using in the use of this building? But it's shifted to a more global perspective. So we look at how much CO2 is emitted during the transportation of getting material to the factory to produce the product that is then installed in the building, and so on, and how much CO2 is in the maintenance of this product when it's installed in the building. So we've shifted from basically producing something, watching what is happening in use, and then thinking maybe about the recycling part, to assessing the whole life cycle. And this includes water by now, and this also includes biodiversity, which is a huge issue, which we underestimate, I think, as humans, because we can't see it as much. We don't really react to things we can't see. That's why the oceans are not of a big issue to us at the moment. But this whole exploitation, or this whole operational use of carbon, or production of carbon, or the production of carbon in the operation of building will remain, but all these other topics will shift in the way we look at buildings, and there's a sort of carbon economy underlying this change. And all that said, it has led to a project we launched over a year ago, which we call Carbon Control, which sort of aggregates the services, the product logic, the things we can combine in one large toolbox to address the carbon emission issues that we have in our product, in our industry. So what is carbon control? Well, carbon control is basically a logic. It dissects the life cycle, as we saw in that regulation chart, It dissects the life cycle of product, adds service, and puts it together into a package where we look into the planning of buildings and facades, the construction, the operation, and the deconstruction. So we have, on the top left, we have design to decarb, we have build to decarb, we have operate to decarb, and we have recycle to decarb. And these areas all look at facades in a bit of a different way and offers a different service logic for the respective quadrant. So in the design to decarb, we have different services and different approaches that we use inside the company. So for instance, we assist in designing the right covering of the building, understanding the amount of aluminium that is needed in this design, trying to reduce the aluminium. If there's a bespoke solution, of course, it's an economic viability. It's the economic viability of a project. If we can reduce the cost, reducing aluminium usually reduces the cost. We have, similar to the algorithms we just saw at Bollinger Grohmann, we have algorithms that optimize the wall thickness of the profile, something you don't see on the outside. What people know from Schüco is that we can optimize the outside shape of profiles, but we can also optimize the depth in different areas of the profile on the inside that you don't see, enforcing the structural integrity, but at the same time changing nothing in the visual design, and in that way reducing the amount of carbon in the product. We've developed products that use the structure of the glass to reduce the amount of aluminium. The minimal wall, which has very, very thin aluminium profiles using the glass and the bonding of the glass as a structural complex, and making the whole CO2 of the facade, reducing the whole CO2 of the facade. Then, of course, we have our systems. This is more in the bespoke, the engineering side, explaining how a project can be optimized, but at the same time we have systems, and of course we increase the quality of these systems and reduce the CO2 in the amount, in the fixings, the gaskets, every part of the product, and of course the aluminium, where we have low carbon and introducing ultra low carbon as well. And in the operational area, the third quadrant of the toolbox, we have all the products and the optimization in the products. For instance, heat exchange, decentralized ventilation, which can reuse 85%, almost 85% of the energy in the air in the extraction and intake. Building integrated photovoltaics in a different color array. We'll be introducing a new BIPV system in the near future. We have green walls. These are not only important for the microclimate in the building, reducing the temperature on the surface of the building, but also, of course, for the microclimate in the area. And they're also important in rain situations. And we have different facade designs, for instance, the active facade, where we have very intricate airflow between the interior shading, the ceiling, a complex system that is super energy efficient. And on in the right, fourth quadrant at the top, there's the IOF, which is our Internet of Facade tag. This is a very, very small little thing. It's a sticker at the moment. It will be a QR code embedded into our fixings in future. And what it does, it hosts information. No more, no less. But it can host the information to the maintenance of the product. It can host the information when parts were exchanged, what parts were inserted. It hosts the information what material is in this product, in what amount, which is important for urban mining in the future. So this is something that can be interesting for the operational period of the building, but it can also be super interesting for the decomposition of the building. And that is that recycling part where some products do have an end of life. There's no maintenance more possible. You have to extract, but then at least do it in such a way that you can reuse it for the building industry. And I say that because the automotive industry needs aluminium very much at the moment. Electric vehicles consume a lot of aluminium, and at the moment we have a situation where there's very little aluminium coming out of the building construction market, and we have to keep that in the construction market because aluminium is a super recyclable product. So let's go into renovation. If we want to use less, we have to renovate. We have to use the structures we have and use them for as long as possible. We just saw that in the Bollinger-Grohmann presentation. Super interesting project, and that's exactly the way we have to go, especially the last project in Düsseldorf, which of course I know. So renovation has always been a large segment of the market, and it will be a growing segment. We all know there's a renovation wave in Europe, and there's going to be pressure, there's going to be money put into it, and it will also be because of the climate change that people will be driving it even more. I said it's an exponential curve. We'll be feeling it harder, and we'll be reacting harder. And in France, the figures are not so different to Germany. We heard already in the first presentation, and Jacques Lador also said it, we have very hard carbon goals, and this means that we have to work on our buildings, our building stock, because the building stock is the largest part of our built surroundings. And in Germany, the figures are the same. If we want to achieve the targets, we'd have to be renovating by approximately 3 to 3.6% of these buildings. De facto, in Germany, it's the same. We're renovating about 0.6. So the speed has to increase massively, and it will. There will be force. So what types of renovation do we have, or what do we see as potential renovation at Schüco? Well, try not to renovate. Try to keep something functioning as long as possible. So maintenance is the first thing. We have an own service team at Schüco that services products. In the Netherlands, we have a service team that services competitor products because we believe we have to keep these things functioning as long as possible. And it is a business. If things break, repair them. Build them so that they can be repaired, which we do. We have a systems tradition, so we can take new fixings, for instance, and introduce them into old systems. We can repair old systems. Not all of them, but quite a few. Sorry, one back. We can upgrade systems. So we can add new gaskets, for instance, and make it airtighter than it was, even when it was introduced. We can refurbish. I'll be showing an example where we put in new vents in an old frame, and in that way we can increase the U value, airtightness, etc. It's not trivial, but it can be done because we have a system logic. And in the worst case, renovate, extract, and put in new. That's the easiest, and that is the most common in large-scale projects. So if we look at our system legacy, these are the non-insulated systems. Then came the energy crisis. We introduced the first insulated systems, and the insulation values have grown over time. They've become more tighter, the systems. They've taken first double glazing, then double glazing with coating, and the change of filling gases, and then later triple glazing. And we've even had projects with quadruple glazing. But some of these systems can be adapted. They can remain in the building. The really old systems that are non-insulated will commonly have to be changed, although we're working on improving non-insulated systems and lifting their U value. We'll be showing that in the near future because there are ways of doing that. And I'm working on a project in the Netherlands where we're doing that at the moment. Or we can change components, we can upgrade them, change the vent, for instance, which I'll show in a second, or just change gaskets, add foam sometimes, and that can be enough to lengthen the lifespan of this product in situ. So I was saying we can take out old vents and put in new vents with new fixings, etc. We've looked at it in different compositions, and you can see here there's a UW value of 3, which by changing the vent with added foam, changed gaskets, we can change that to 1.1 in situ. And this is not something we can do in every project. We have to look at it very intricately because there's building physics. We don't want mold in the building. We have to look at everything in the situation in the building. But we have looked into it, and it is possible, and it's possible because we have a long-term system logic. Other variations are taking the old frame and putting on a renovation frame, inserting a whole new window in the same place. Again, we have to look at the specific building. It's a project solution, but it can be done, and we are doing it in different projects for quite a while now. Other minimally invasive tech is adding layers to an old system in facades, for instance. So similar to what we saw in the windows, we can do something like that in stick constructions. It's actually not as complicated as you could see in the video. And if structurally capable, we can even upgrade the quality of the glass in that area. And the next level would be to completely install a new facade on the outside. We have systems that can span from ceiling to ceiling while the building is in use. Add a facade layer from the outside, leaving the old windows in place, adding BIPV, for instance, solar shading. We heard solar shading, and I said heat is the biggest killer. Adding solar shading to the outside, adding a decentralized ventilation on the inside, and then when the office area at a certain time of day or in a short period of time is not occupied, extract the old windows, and the new facade is already in place. And another nice little unspectacular solution is to add space on the outside of a building. And you can see this is a relatively typical old residential building. This is a new situation. I get that it's not super architecture, but the logic of the product is quite interesting, where instead of having to add a lot of insulation, you just put one layer of balcony, which is insulated in the front, adding space, adding basically a winter garden, and at the same time reducing the amount of effort putting into it and adding new possibilities of architecture to the outside layer with the insulation area. So you can see it with a glass spandrel, or you can see it here, if required, leaving it with the concrete spandrel. And with that, I'd like to come to an end. We are part of the problem, every one of us. It's not a business that is creating CO2, it's people actually doing it. It's us driving cars, etc. But at the same time, we're part of the solution. So we are very ingenious as a group. We're very ingenious at developing new things. We enjoy doing that. And if we work together, we can achieve quite a substantial amount of improvement. So with that positive note, I'd like to thank you all and hope to see you in the conference area later.